Good morning, friends. Now we are discussing velocity of sound wave in the fluid in module number 5, that is compressible flow, of the subject fluid mechanics. So velocity of the sound wave or the pressure wave in a fluid. So here there will be a disturbance in the solid or liquid or gas will be transmitted from one point to another. So the velocity with which this disturbance created is transmitted depends upon the distance between the molecules of the medium. So the velocity of disturbance in case of fluids is less than the velocity of disturbance in the solids, whether it is solid or liquid or gas. So the disturbance created inside the body is getting transmitted from one point to another point. So the velocity of this wave, disturbed wave, right? So it is depending on what is the distance between the molecules of the medium. So in case of fluids, the velocity of disturbance is less than the velocity of disturbance in solids. So now we have here uh, the fluid flow where we are fitting a piston in this pipe. So the disturbance creates the pressure waves in the fluid. So these pressure waves will travel with the velocity of the sound waves. So take a long pipe of uniform cross-sectional area throughout. So that is fitted with a piston. So A, capital A is the cross-sectional area of the pipe. V is the velocity with which the piston is moved. So P is the pressure of the fluid in the pipe before the piston is getting moved. So dt is the small interval of time with which the piston is moved. So the piston is allowed to move for a certain period of time dt. So c is the velocity of the pressure wave or the sound wave that is traveling in the fluid. So c is shown here, the velocity of the pressure wave or the sound wave. So the piston is moved over a length, so that is x. So distance traveled by the piston in the time dt. So that is v into dt, because we know that velocity is distance by time taken. So distance traveled is velocity into time. So v is the velocity and dt is the time taken. So distance traveled by the pressure wave. So pressure wave velocity is given as c. So distance traveled by the pressure wave is now given as c into dt. So the piston has moved over a small distance x here, and the pressure wave has traveled a large distance L here. So piston moves for a distance of x, whereas the pressure wave is moved over a length of L. So that is given as C into dt. So C into dt is more than V into dt. So length L is greater than x. So C dt is more than V dt. So let P plus dP is the pressure after the compression. So that is the pressure created in the pipe. So rho plus del rho, that is density of the fluid in the length L minus x. So as the pressure changes, so density also changes here. The fluid is getting compressed. From continuity equation, so we say that mass of the fluid before compression is equal to mass of the fluid after compression. So mass of the fluid, so that is nothing but, so we know that density is mass by volume. So mass is density into volume. So where density is rho into volume, so that is area A into length L. So where length L is given as C into dt. C into dt. Mass of the fluid after compression. So after compression, density is now increased to rho plus del rho into A into the length. So what is the length now? It is C dt minus V dt. After the piston is moved over a distance of x, so the distance now left is C dt minus V dt, L minus x. So dividing by A dt on both the sides, we have A dt on both sides. So we have C into del d rho. Okay, is equal to rho v plus v into d rho. So dividing on both sides by A dt. So the velocity v is very small compared to C here. So velocity. So V is the velocity of the piston. So that is very small because the piston is moved over a small distance. So V is very small compared to C. Also the value of d rho, change in the density is also very small. So hence the product V into del d rho is ignored. We have C into d rho is equal to rho V. So here V into d rho is ignored. Applying impulse momentum equation, that is the net force on the fluid is rate of change of momentum. So net force on the fluid is P plus dP into A minus P into A. So that is the net force, the final force minus the initial force. So is the rate of change of momentum, mass per second into change in the volume of the fluid. So when the piston moves with a velocity v for the time dt, the fluid at rest is also moving with the velocity of the piston v. So the pressure of the fluid will also increase from P to P plus dP. So change in the pressure is now the difference of these two. So we have now dP into A is equal to, so rho A into C dt divided by dt into V minus 0. So we have on simplification, we are getting C is equal to dP by rho V. Multiplying the two equations 1 and 2, we are getting C as C square as dP by d rho, and C is the square root of dP by d rho. That is the velocity of sound wave equation. Thank you, friends.